Okay, let's do the manifold burst panel part. It's extra credit, but I still will mark you off if you do not have your name. The title is manifold burst panel. I'm going to say OK. And the file name, I'm going to save as on my desktop. It's going to be Buchler M manifold burst panel. And I'll start with a sketch on, let's just use the top. This is not in the book. So I'm going, I did it again. I'm going to switch that template. Let me start again. Sketch, now that I'm in inch, pound, second unit of measure. I'm going to start with a horizontal line. And then there is a little flat section here. It's 250 thousandths. I'm going to go back to the arc function, another line using the inference lines here. And then same thing here. I can use these inference lines pretty good to make a almost symmetrical shape. And let's look at some of these sketch relations as I added as I went. So in this case, I was able to use the line function to make this arc, and it actually made both endpoints tangent. So you can use that in this case along with the inference lines. I'm going to smart dimension off the drawing. Just this line length is 4.375. The overall height is 2 inches. Now from here, I'm going to add a center line, and I'm just going to put it right here in the middle. And I'm going to make these 3 lines. I should be able to make these 3 lines symmetrical. So now I can move this line back and forth. This line will stay in the middle between these 2 lines. So there's exactly 1 inch on both sides here. Now I'm going to make this point and this line and this point collinear. Yeah, but before I do that, I'm going to add the dimension 4 here because I have the tangent tolerance. It won't fold over itself as long as I smart dimension this radius. Off the drawing, I'll make this radius I just dimensioned, this radius I just dimensioned as equal in size. And now I'm going to go ahead and make this point, this line. Can I make all 3 of them? Not symmetric. Let's try and do 2. Just this one and this one as coincident. Not collinear, but coincident. And now I can actually make this point and this point horizontal. So that's the same outcome there to make those constrained. And then there's another dimension here, and I'm just going to use the line length. This is 0.25. And then the same thing here, this line length is 0.25. Okay, oop. What about this line? This is not collinear, so let's make, and if you saw that, I dimensioned this line length instead of like edge to edge, and it wouldn't have mattered because these lines are separate. So let's make these lines, let's try it this way, these lines collinear. And then what about this one? Does this one move back and forth? Yes, it does. I can do a different sketch relation. Let's make this point and this point vertical. So kind of a different sketch relation. It still gives us the same constraint. Okay, so this looks pretty good. I can move this all over. Let's just go ahead and make this point, hold control, and make this point, the point origin, coincident. And I think now that shows that we are fully defined down here. So this looks good. There are some fillets here on the drawing, and I'll put them in now. I might as well put them in now as sketch fillets. Sometimes that can be an issue depending on how you dimensioned the part, but I think we should be okay with 40 thousandths sketch fillets here and here, here and here. I'm going to say done. And that's pretty good. I'm going to say yes. Oh, I got out of it. Actually, I wanted to stay in that. I'm going to, oh no, I got out of the dimension tool. Okay. So I'm still active in Sketch, and if you noticed on my center line here, the endpoints are blue. I can move this length, but it shows this as fully defined. So it doesn't matter what this line length is. This is just for construction. So this looks good. From a fully defined sketch, I'm going to select Features, Extrude. And this one is so basic, it's not really going to matter if I do a mid-plane. I'm just going to go part thickness 250, and this looks good. It's got I noticed on mine, it has a little fillet on this edge here. So I think I'm going to go back in and make sure what's going on here. I'm not sure why this was added. So let's make it, drag this across to here, do a little trim to fix this, and I'm still fully defined. I must have inadvertently selected when you do the sketch, the sketch fillet, if you select a point, it can add it as a point. So sometimes we inadvertently add features in wrong dimensions. In that case, I was lucky to kind of see that visually once I looked at my extrusion, and now it shows a sharp corner there. So just 4 fillets, 1, 2, 3, 4. And you definitely want to always rotate and look at your part visually, compare it to the drawing, make sure you're using the visual clues to make sure your parts are correct. So from here, I'm going to do something new with us. You ready? Let's use the whole wizard. I'm not going to start in a sketch, but it's going to actually ask us about a sketch plane, and this function's pretty good, but maybe it could be better. I'm going to select from the Features tab the whole wizard. And I'm going to go kind of quick because I'm going to actually do this as a regular assignment late. I want to say next week, but maybe in 2 weeks. Before I don't, probably do it before the midterm here. And it gives us 9 selections. In the property manager, there's actually 2 tabs. There's the position tab. This is where we're going to select our sketch plane, and we're going to dimension on this tab here. But on the type, it gives us 9 selections: counterbore, countersink, hole, straight tap, and I don't like the terminology. This should be called a threaded hole, not a straight tap. This is the threaded hole. This is a tapered tap, a legacy hole, and then slot, countersunk slot, and counterboard slot. So it's gray. You can see that it's gray here and it's highlighted. So I need to go down, and the bottoming tapped hole gives you a little less lead for the drill, in case you could potentially drill out the bottom of your part. In our case, we can just use tapped hole. It doesn't really matter actually because we're going to select through. The hole size on the drawing, I can just kind of rotate through with my wheel mouse. It's quarter 20, or you can go to the drop down and go to quarter 20. It doesn't show the class of, or the series of thread as a unified national course as shown on the drawing, but that's what it is. It's a machine thread. Of course, we're just modeling. We're not actually creating, machining the part. So it's important for, might not necessarily be important for the design, but in the manufacturing, that is important. I'm going to go through all, so the depths don't really matter. So again, I've got a straight tap with a bottoming tapped hole or a tapped hole. It wouldn't be a pipe thread. It would be one of those two. It's going to be quarter 20 through all. That looks good. Once I'm done with this selection, and this is the view too. I'm not too concerned with the view. So I usually have, the default is like a cosmetic thread, so we'll see what that looks like when we're done. Once I have my type in the property manager filled out correctly, I'm going to select positions, and it asks me for a face. And once you select the face, you'll see it will give us a preview here of the hole. And I'm just going to go put, you can do it a few different ways. You can do a single hole and a linear pattern, which is what I did on the test tray. And I actually think that's easier. So that's what I'm going to do. If you do all 6 holes or all 8 holes here, you have to dimension each one. And I think it's a little more difficult. So I'm going to just do one. I'm going to say yes. It's a little tricky here because you're still in feature tab. And this is the one wonky thing about the hole wizard is I'm going to say yes. And then it shows the hole, but I have to actually go back in, and there's 2 sketches in the hole wizard. There is the profile of the threaded hole. And in this case, it shows it fixed on the face I selected on the center. And this is going to be dimensioned right now. I'm going to show you. It shows a center line, and it shows a profile of the hole. In this case, it doesn't. It just shows, I believe this is the minor diameter. Yeah, it's the minor diameter because this is a 201, which is our tap drill size for that hole. But it doesn't necessarily show the thread in this profile sketch. I'm going to exit that sketch. You're going to need to go in and edit this sketch. I'm going to right click, edit sketch, and then I have a point, and I need to dimension the point from this edge off the drawing to here. And it shows 0.875. And then off of the point also, off of this edge, I don't think I selected that right. Let me try that again. In Smart Dimension, either order this edge to this point. I'll bring it out over here. That's right. I need to do a center line. It's actually dimension on the center line, and I don't have it on the drawing. I think I missed that on the drawing. I will actually try and go back in and make sure I have a center line on the drawing. I'm going to remove this dimension, and I'm going to add a center line from here. to here. And now I'll just smart dimension from center line to here. This as ½ inch. Now it shows this underdefined here on this sketch. Let's exit the sketch, and I don't want to do that. I don't want you to leave this underdefined. I'm a little surprised because I thought when I did this center line, it was coincident point to point. So I'm not too sure why I can, that's what it is. All I need to do is go in, select the line, and make this a horizontal line. And now I'm fully defined. So let's define that center line just in terms of, I don't even think I need, let's see, do I need one of these? I probably don't need. Oh, actually, let's go back. One, another, and it's this one I don't need, because this one is actually coincident with the midpoint of that arc. This one was not. It was just coincident with the edge. So there's a little bit of a difference, and now it shows they're as fully defined. So it's just dimension the point in this sketch within the hole wizard. That's the location of the center of the hole. I'm going to exit the sketch. It goes back to showing me the hole, and I can see that it's now fully defined. So let's see. I believe these are symmetrical. So let's see if they are. On this one, I might actually have to calculate at least one or two of them to determine if that's correct. So I'm going to use the, like we did on this week's assignment, the test tray. I'm going to use the linear pattern. I'm going to use this direction and this direction. In this case, I'm going to have 2. And in this instance, I'm going to have 4. Yeah, 4 total. The linear distance is going to be, for edge 1 along the length, I'm going to go 1.755 minus 0.875. And then the other direction is pretty easy. It's 1 inch, right? 1 inch. And in this case, if I open the flyout menu, I'm not too sure why, but it didn't self-populate the feature to pattern, even though it only has one feature. It has the base and one feature. So I'm going to actually go in and select, and that looks pretty good. I'm going to say yes, and that's the part. Now, I haven't checked this. The way I dimension this, I actually dimension it from one edge. So when you do this linear pattern, I have yet to check this. I'm going to check it this way. Let's smart dimension from this edge to here. 3.52. Let's go to a 3-place showing. And let's go to even more so I make sure it's correct. 4-place decimal, 3.515. So even though I didn't use the accurate dimension I didn't locate this part from this edge. It's actually patterned from this hole. The pattern I use, I could check that real quick. Just going to any sketch tab, even in the graphics view, I can just at least check that. So that's that. So make sure summary information is in there, and I will hopefully speak with you Wednesday or Friday, depending on your class, and you can always ask questions in the discussion. Okay, thank you.